Today we're going to be covering topic 3, measures of central tendency. Just as a reminder, you have a frequency review quiz on Canvas that will help you make sure you understand topic 2. It can be done at any time up to midterm 1. So here's our roadmap for our central tendency. We're going to cover mean, median, mode, and so forth, distributions, and summarizing research. This corresponds to chapter 3 in your textbook. All right. So measures of central tendency summarize the location of a distribution on a variable. Okay. It's all to answer the question, where do most of the scores lie? Okay. Are they generally high or generally low? So we might talk about, well, how did the class do on the midterm? Do people do on average well or poorly, right? And the 3 measures of central tendency are the mean, the median, and the mode, okay? They all indicate where the center of the distribution tends to be located. So you guys know about the mean. This is just the average or mathematical center of the distribution. We use this to summarize interval or ratio data, okay, in situations where the distribution is normal or symmetrical. We talked about that last week. We talked about normal distributions, and then we talked about skewed, positive and negative skews. So when we have a normally distributed variable, the mean is the most appropriate measure of central tendency, and you just add up all the numbers and divide by n, right? Or the number or the total frequency, right? So let's start out with a quick review quiz on Canvas. Please pause this recording and open up the lecture 3 points extra credit quiz and find the mean of the following variables. When you're done, you can continue. All right, so we talked about in the first topic about how we use Greek letters to denote population parameters, right? So the population mean is denoted with Greek lowercase letter mu, okay? The formula is the same as the formula for a sample mean, which is just add up all the values and then divide by the total number of values. Now, an important concept that we'll be using over and over again throughout this course is the idea of deviations. And this is just the distance between a single score from the mean of a distribution, right? So if we have the distribution of exam grades in this course, we can get the average or mean of it. And then the deviation for each score for each one of you will just be the difference between your score and the mean. So say you take the first midterm and the mean grade is 75%, and you have a 70%, where the deviation for your score would be 70 minus 75, which is minus 5, right? So let me write that out so you can see it clearly. So for example, let's say the class takes the midterm and the mean equals, let's say the mean is 76, okay? And let's say Charlie takes the exam and gets a 72, okay? That's Charlie. Charlie's deviation is just 72 minus 76, that's a 6 there, equals -4, right? If Susanna had a 77, Susanna's deviation would be 77 minus 76 equals 1, and it will be positive, all right? Okay. So this is just basically the error in prediction for that individual score when we use the mean to predict scores, right? The sum of all the deviations is always 0, right? Because to get the mean, we add them up and divide by n. Now, the second measure of central tendency we'll be using is the median. This is just the score or value at the 50th percentile. You put the scores in order from smallest to largest, or vice versa, it doesn't matter. Find the one in the middle. If there's an even number, take the mean of the 2 in the middle. We use the median to summarize ordinal or highly skewed interval ratio scores. So remember when we talked about population, the distribution of income in the population of the United States more or less looks like this, right? There are a few people who make a whole bunch of money and most of us don't make very much. So we wouldn't want to take the mean because it will be way out here, which will give a false impression of what most people make in this country, right? So what we take is the median, which is probably somewhere around here, right? Right? Where 50% of the scores lie above and 50% of the scores lie below. And this will be the most appropriate measure of central tendency for highly skewed variables, and for this one in particular. When with a normal distribution, remember the mean, the median, and the mode are the same. Right, so for example, if we wanted to get the median for these scores, first we'd have to put them in order, right? Then we would find the one in the middle, right? So there's 4 scores below it and 4 scores above it. Here's another example. What if we have an even number of scores? There's not going to be one in the middle, but we still line them up in order. We take the 2 in the middle, add them up, and divide by 2, and we get a median of 6. All right. So 50th percentile. Percentile is just percent of all scores in the data that are at or below a score. And we saw that last week, and we showed how SPSS gives you what it calls cumulative percent, which is actually a percentile. To calculate the percentile, you just divide the cumulative frequency by n and multiply by 100. So let me pause. Remember that the 50th percentile, which has 50% below and above, is always the median. The mode is just the most frequently occurring score. This we use with nominal scales of measurement. For example, religion, we might want to know, okay, we have a sample of BC college students, and we've asked them what religion they identify, if any. And we want to know, well, what's the most common religious belief or religious preference in this population? So we just count them up, right? There are 2 types of distributions we're talking about as far as mode goes, unimodal and bimodal, right? So say we have 65 Catholics, and that's the mode. There's nobody who has more than that, right? Maybe 60 Protestants, 20, whatever, right? But what if we had 60 Protestants and 60 Catholics? It would be bimodal, right? 2 modes. And here we have an example of test scores, but we really don't need to use this mode when we have interval ratio data. So here again, normal distribution, the mean, the median, the mode are all the same. So we can clearly see right there, this is frequency. Most frequently occurring score is also right in the middle at the 50th percentile, which is also the mean. In skewed distributions, when you have a positive skew, the mean is pulled falsely upwards, right? So the mean is going to be higher than the median and the mode. And for negatively skewed distribution, it's going to be the opposite, right? The mean will be pulled downwards, and it's going to be lower than the median and the mode. Okay, so now I'm going to talk briefly about summarizing research. And we've talked about a lot of this when we talked about graphs last topic. So to summarize an experiment, you kind of want to compute the mean, measure central tendency of the dependent variable in each condition. All right. So for example, we'll be coming back to this example frequently over this semester. A lot of people think that violent video games cause people to be more aggressive in real life. So experimenters could bring a group of people into the lab and randomly assign them to play either a violent video game, such as Grand Theft Auto, or a non-violent one, such as Tetris. And then they measure them on some variable that would operationalize aggression. Frequently, people use hot sauce, so allocating hot sauce to a poor, innocent person who does not like hot sauce. Of course, the person in the experiment does not know that. They just think they're setting up for the next experiment, right? So if we have people play either violent or non-violent games and then assign hot sauce, we measure how much hot sauce they assign, and then we figure out the mean allocated hot sauce for each condition, violent versus non-violent, right? So that just summarizes the mean for each condition. A relationship is present, that is between, in our example, playing violent versus non-violent video games and aggression, if the means from the 2 conditions are different. So we can use different graphs that can show us the relationships between variables or allow us to compare variables. We already talked about scatter plots. Let's look at a bar chart. So for example, in our class data set, we asked people how many hours they spent on social media. We also asked them whether they had a job or not. And we found that, this is the data. This is from our actual data. And what we found is it looks like from this bar graph, the people who have a job actually spend more time on social media. Again, this is from fall 2022. Your data is probably slightly different, and you will be calculating this yourself and making these graphs yourself. So here we have mean hours spent on social media per week and whether people had a job or not. And we can see the mean for those who said yes is pretty close to 15. And the mean for those who said no is below 10. So it looks like people with a job spend more time on social media. Here we have mean hours studying on the y-axis. So mean hours studying, and again, our job variable. And interestingly enough, we can see that people with a job also study more. Apparently, people with a job have more time for everything. So again, bar graphs are used when the independent variable is nominal or ordinal, right? Okay, so here we have our independent variable, in this case, physics, psychology, and English, right? And here we have mean recall errors when they're asked to memorize some words. And we can see that people, curiously enough, in this funny example, with the English major, made more recall errors. We can also use line graphs, okay? This we use more frequently when the independent variable depicted on the x-axis, right, is not ordinal or nominal when it is continuous. So here is a length of the list for words people have to memorize and their mean recall errors. And you can see that the longer the length of the word list, the more errors people made, not surprisingly. This shows a correlation between these variables here. Here is an example from your own data set or the data set from last semester, but you'll be doing it for yours as well. So this shows how many hours spent studying per week and how many hours on social media. And you can see that the more time people spent studying, the more time they also spent on social media. You see that positive slope here, right? Here we have another relationship. We have study hours, how much time spent studying, and mindset. And mindset was that last variable, last questionnaire you guys completed on the day one survey that asked you questions like, your basic intelligence can't ever really be changed. And you indicated whether you agreed with that or not, right? Or you can always change your basic intelligence. Higher scores on this mindset variable means you have a growth mindset. That means you have greater beliefs that you can change your intelligence. Lower scores indicate a fixed mindset, which is the belief that basic intelligence can't really be changed. And you can see from this scatter plot that the more people believe you could actually change your intelligence, the more they tended to study. Here we have a new scatter plot which depicts the relationship between high school GPA and work hours. And here we have basically a flat line. We can't say anything about how many hours people worked based on their high school GPA, right? There's no relationship between high school GPA and the amount of hours people have to work. Not surprisingly, no matter how well or poorly you do in high school, most of us have to work, right? Okay, finally, we're very quickly going to cover box plots. So box plots are kind of useful. In a box plot, you can see a lot of information. It gives you the median, right, or 50th percentile. It gives you the interquartile range, which varies from the 25th to the 75th. It shows you these are the whiskers, right? Right, whiskers are these lines here. And this is just with an idea of all the data without excluding the outliers, right? And then we have outliers, which depending on what it sets, okay? So quartile 1 is 1.5 times interquartile range, depending on how you determine it. They're the ones who have extreme scores, either extremely low scores here or extremely high scores here. Now, most statistical software programs give you box plots in the vertical sense like that, right? So again, you have the median, the entire quartile range, you have outliers, and then you're excluding the usually 5%, the minimum maximum score was excluding 5% outliers here. It depends on how you set it, right? The same thing here. These are outliers, median, and so forth. Here's another example. This is actually from Jamovi, and we can see these are real data, right? And we can see here we have a normally distributed variable. We saw that last week. We have the median right here. We have no outliers. Here we have compassion, which is a negatively distributed variable with those extremely low scores, which are low outliers, right? And let's look at how that corresponds to our distribution. Okay, here we have, on the one hand, we have our histograms here with the normal curve drawn on, right? This is again from Jamovi, but you can do the same thing in SPSS. Here we have a basically normally distributed variable, and here we can have, see those very low scores, extremely low score? That's 1 here actually, or maybe 2. And we can see this is self-esteem. We have a few, 1 or 2 people that actually have reported very low self-esteem, but most people have reported high self-esteem. Here's an example from SPSS, right? We have an example of moral identity, which we can see is a negatively skewed variable with some extremely low scores, and most are high. Here's are those low outliers. And here we have moral contagion, which is the opposite. We have most scores are low, and then some high scores, which are outliers. So this is positive skew. And this is negative skew. All right, so next, don't forget to do your SPSS lab and SPSS worksheet.